Guys, welcome to another episode of Cuda Education. Uh, this is the Vulkan API series, discussion series, and we're on the triangle.cpp algorithm. Shout out to Sascha Willems for creating this algorithm. It is freely available on GitHub and accessible to everyone. The topic of this video is semaphore. So um, if you guys want to really know what I'm talking about, make sure you check out the previous video, which was a whiteboard edition, triangle.cpp whiteboard edition, where I basically diagram out a whole bunch of stuff related to this. As you can see, this is a triangle algorithm, right? So we create a triangle, as you can see here, and the triangle is beautiful. Basically, what happens is that we are basically going to discuss semaphores. Now, a quick refresh: semaphores is GPU, the GPU synchronization. So two processes on the GPU, right? GPU synchronization. Two processes on the GPU, and we have to make sure that one doesn't happen while the other one is occurring. So we have an image here. Let's say this is an image, right? And then before we can, the image is normally blank. Upon creation, the image is blank. There's nothing in the image. We have to draw the triangle, color the triangle, all that stuff, right? So there's a drawing phase, which in this algorithm we call render. And then there is the render complete semaphore. So there's a drawing phase, and we use a render complete semaphore to signal that it has completed. And then we have a present complete semaphore, and that basically tells you that the image has been presented to the screen. Now the image can be cleared and refreshed and redrawn upon, and then represented, right? So we have a drawing phase and we have a presentation. Right now, what we're looking at is, of course, the presentations. Pixels actively being drawn in a windowing system on our monitor. The light from the pixels is leaving the monitor and coming to our eyes, and we're able to see this triangle here. So that's pretty much it. So there are two semaphores that are involved, and that's the topic of this video. Now, really quick, if you guys want to join in on the fun, tutorial number 1 and tutorial number 13. You need to get those two tutorials. They are linked in the description below. Tutorial number 1 is installing a Vulkan API, the Vulkan API on a Windows-based machine with a Vulkan-capable GPU. Tutorial number 13 is installing these examples. It's not just one triangle example, it's many examples. So my strategy is that I'm using the examples to learn Vulkan. All right, so here we have it, this triangle application. As we've been seeing, we're now at 4,600 frames per second, which is really cool. There are a couple other triangle examples on the internet, but the others don't necessarily allow you to rotate the triangle, just a static picture on the screen. All right, so let us do render complete semaphore. All right, now again, guys, if you want more context into this discussion, you have to watch the previous video. It's a whiteboard video where I'm diagramming stuff out on the whiteboard, and you will get more information. Here now I'm just showing you in code. This triangle application is 1,000 lines of code, so we just have to plow through it piece by piece. So I'm focusing on a specific topic, and we work our way through it. I'm not doing the whole thing because I would lose you guys. All right, so render complete semaphore. So again, render complete. Render is a fancy way of saying draw. So draw complete. We're finished drawing, right? We have to draw the triangle before we can present it to the screen. So we have render complete semaphore. So here we're just creating a simple variable of type VK semaphore. Nothing special is happening with this variable. We haven't changed the world yet. It's just a simple variable being created called VK of type VK semaphore. Okay. We practice good housekeeping here at Cuda Education. So any variable you create, you have to destroy it also. This is a the destructor. Okay, nothing special yet. Okay, now we're in the function prepare synchronization primitive. So we're preparing our semaphores because we know we have two processes that we have to basically synchronize. In our case, it's one process can't happen while the other one is happening. So we can't be drawing a triangle while we're presenting. We can't be drawing the triangle on the canvas while we're trying to present the canvas to the world, right? Through your monitor. We have to draw the triangle first and then present. Okay. And then, there's a process where we clear out the image after it's been presented, and we redraw again, and then we present again, right? But while we're drawing, we can't be presenting. So that's what so one of the semaphores is render complete semaphore. Now here we're actually doing something. We have a lowercase vk function. Anytime you have a lowercase vk function, you kind of know that it's like core Vulkan API stuff. So now we're actually creating something. It's not just a simple variable. We're not just, creating a simple variable of a certain variable type. We're now doing something. So we have this vk create semaphore function. You guys could look it up on the spec, but basically we have this function, and we we encapsulate what it creates into render complete semaphore. So now render complete semaphore means something. Now it has something of substance inside of it. It's not just a simple variable anymore. Okay, and then of course we have our device, which is the GPU that we're running, and we have create info stuff, which is, we're encapsulating information. All it is information. Create info is just information. We got to tell Vulkan API all this stuff, and we got to encapsulate it into this, so that when we call the function, the Vulkan function, that it actually knows what you want. Okay, so now render complete is a semaphore, and it means something. All right, so let's move on. Now we're in the draw function. So now we're in the drawing phase. We're drawing something, right? We have a blank canvas, a blank sheet of paper, a blank image, but now we want to draw a triangle, right? So that's what this function is all about. See, it says draw up here. We're trying to draw the triangle. Notice that in sort of this is another kind of create info situation where we're encapsulating a lot of information, but notice that we have our signal semaphore as render complete semaphore. Okay, semaphores to be signaled when command buffers have completed. What does that mean? So once we're done drawing, render complete semaphore has to be signaled in the signal state. It has to light up. It has to tell the world, hey guys, we're done drawing, right? That's what this signal semaphores is about. So signal semaphores, of course, has the render complete semaphore, because once we're done drawing, we have to signal the render complete semaphore to say that to tell the world that we have done drawing. And of course, you have your signal semaphore count as 1, because we only have one semaphore. Okay, I discussed this in the whiteboard video previously, the video directly before this one, right? So we have our signal semaphore count as 1, render complete semaphore. All right. We have our render complete semaphore. Okay, so let's just move on. Right now we are doing swapchain.queue_present. So now we're actually you could read these comments up here, but basically this ensures that the image is not presented to the windowing system until all commands have been submitted. This ensures that the image is not being presented to the windowing system until all commands have been submitted. What this basically means is that we're not going to show the image of the triangle on the screen until the drawing of the triangle is done, right? So we have to, we include render complete here. This is a wait semaphore. So this is the wait semaphore. And we're saying, hey, do not queue present, do not present if this hasn't been signaled as complete yet. If we haven't, if we go into this queue present right here, if we go to definition, we're going to see that this function, as one of its parameters, is the wait semaphore, right? So remember, the wait semaphore is we want to wait that this is complete before we proceed, right? So this render complete has to be complete, has to be done, has to be finalized before we get to present the image to the screen. So our drawing has to be done before we present the image to the screen. So that's why this parameter here, render complete semaphore, is being called. And that's basically it, guys. It's not rocket science. Believe me, it's not rocket science. So we create a simple variable. We destroy the variable, good housekeeping. We create the semaphore now with the lowercase vk create semaphore function. We make sure that's part of the draw situation, that as part of the draw situation, we have render complete semaphore as a signal semaphore. So basically what that's saying is that once this process is complete, we have to signal this semaphore, and this semaphore is render complete semaphore. Once the drawing is complete, we have to signal render complete semaphore to say, hey guys, I've finished drawing. And then it's being called again down here, but it's being called again down here, but basically as part of presentation to say, hey guys, we want to present this image, but we have to make sure that this semaphore is complete, is signaled, is complete, wait semaphore before we present. Once it's complete, then we can present. That's like the restraint on the proceeding with this function. And that's it, guys. It's not too bad. So the next semaphore that we have is present complete semaphore. Okay, so present complete semaphore, real simple. We're creating a variable of type vk semaphore called present complete semaphore, and we destroy the variable. And basically, semaphore used to ensure that image presentation is complete before starting to submit again. So yeah, so like we present complete semaphore. So we've presented to the windowing system and it's completed. We've finished presenting to the windowing system, right? So that's what this is saying. And we do vk create. We do vk create semaphore. So this is a real Vulkan API function now where we're creating the semaphore, right? So before it was just a simple variable, but now we're creating the semaphore. So now this present complete semaphore actually means something, right? So then once we do that, okay. Right, so now this variable actually has some substance behind it. It's not just a simple variable, okay? So then get next image in the swap chain. So we have to get the next image in the swap chain, and if we go to acquire next image, so remember in the whiteboard edition we talk about a swap chain, which is just a series of a queue of images, right, lined up one after the other. So we're going to get the next image in the swap chain, right? This is the draw function. So we want to draw on the image, but in order to draw on the image we have to acquire the image, right? So acquire next image. We go to definition here. This is sort of the first parameter. Present complete semaphore, optional. Semaphore that is signaled when the image is ready for use. Okay, so what that means is that, remember, we're in the drawing function, so we want to draw, but we have to make sure that present complete is signaled. We have to make sure that the image has already been presented before we could take it. We could take it at the image and start drawing on it, right? It kind of gets confusing because remember we're in a circle, right? So we're doing one thing after the other. Semaphore that is signal when the image is ready for use. So basically we have to say, is the image ready for use? It's only ready for use once present complete semaphore is signaled, right? Which means that presentation is complete, or presentation hasn't happening, or presentation isn't actively happening. And now we could take that image um, and draw on it. We could take that canvas and draw on it, right? That's that. And then also present complete semaphore is used down here. Now remember, we still are in the draw function. So here we're acquiring an image, we're acquiring a canvas, we're acquiring a white piece of paper, right? We're acquiring a white piece of paper that's blank, and we want to draw something on that white piece of paper, okay? But in order to draw something, we have to make sure, we have to wait. Again, we have to wait to make sure that presentation isn't happening with it. So we're sort of it's sort of baked into the command buffer structure of it. So remember, we had our signal semaphore, but now um we have a wait semaphore. So we're waiting to make sure that this isn't actively happening before we actually proceed to draw. Okay, so that's it. I know the the present complete semaphore it's a little bit rougher around the edges, but you guys kind of get the drift of what I'm saying, right? We have to acquire the image, and then this is like the command buffer where we're actually commanding to draw now, right? But we have it baked into this also. And that's our semaphore discussion, guys. Semaphores, GPU, two processes that are happening on the GPU. It's one GPU, but it's two processes happening, and we have to make sure one isn't happening while the other isn't happening. And that's your semaphores on Vulkan. And there you have it, guys. I don't really have any more to say. I want to just conclude this video by saying, if you're artistically inclined, if you like art, if you like creativity and stuff, learn Vulkan. It's going to help you in more ways than one, and it's going to set you apart from all your peers. So get a group of your friends together, work through the freely available videos I have on YouTube. I also have the tutorials where it walks you through installing Vulkan and also installing the examples. And you could tinker with the code. It's a long-term process. Nothing happens overnight. So start on your journey now. All right, guys. Thank you. Thank you for listening to Cuda Education. I will have another video, maybe talking about fences next. But that's it. That's it, guys. So have a great day. Bye.